All right, hello everybody. Today we're going to talk about shifted parabolas. Yesterday you guys saw that they had two components to them. You could have an x squared parabola, which was up like a cup or down like a round, or the y squared, which went left or right. Now, when we get into the shifted stuff, I wanted to let you guys know a little secret. What happens here and with the shifted things is that the formulas themselves are stored on the calculators. This is going to be this unit and everything. It was always one that I would allow you guys to use the calculators because I wouldn't make you memorize or any of these formulas. So one easy place to always know where all of these formulas will be is the button that says Apps. You hit the button that says Apps. Your screen might look a little bit different than mine. Basically, you're looking for the one that says conics. If I'm not mistaken, over the past few years, I was able to go through and update everybody's calculator that was in my classroom to be able to see that they have the conics button. So if you hit enter here, and then you'll see that you've got 4 different conic sections. Obviously, we've got circles, ellipses, hyperbolas, and parabolas. Since we're talking about parabolas today, I just wanted to show you what it looks like. We have 2 formulas here. We've got the y squared parabola and the x squared parabola. If you notice, you'll see that in the image, y squared, you'll see it has it opening to the right, and x squared, it has it opening up. So this is one way that you'll be able to tell that if it's a y squared, it's going to either go left or right. If it's an x squared, it's either going to go up or down. Now that depends on where this value up in front is. Remember, if it's positive for a y squared, it opens to the right. If it's negative, it opens left. Same thing with the x squared. If it's positive, it opens up. If it's negative, it opens down. So let's take a look at this a little bit closer. So we've got the 2 formulas, y minus k. Gee, I wonder what h and k stand for. Quantity squared is 4p. Remember, p is the distance from the vertex to the focus, x minus h. And what I want to do here real quick is just kind of run you through an example of how do we pull out all the information right off the bat. We'll use this one here. We'll say y minus 1 quantity squared is negative 4 x plus 2. So right away, whenever I have a problem like this, I'm going to the other formula here, x minus h quantity squared is 4py minus k. Now, one thing I want you guys to notice is that when you have y squared on the left or x squared on the left, whenever it's a y squared parabola, I guarantee half of you guys will make the mistake of the values of h and k will always be the vertex. But look what comes first in the formula here. K comes first. This is where most of you guys will make your mistake. So we know that hk is the vertex. The p is still the distance from vertex to focus. And then the opposite of p will be the vertex to the directrix. So we go through the whole scenario like we did before. So in our first example here, what I want to look at here is we have an h value of negative 2, because it's plus 2. And we have a k value of negative 1. I'm sorry, positive 1, excuse me. So our vertex would be at negative 2 and 1. Okay? So from there, I'm just going to kind of do this to start. Okay? We know the vertex is at negative 2 and positive 1. I plot it there. Next, I know that I have a negative 4 in front of the x plus 2, excuse me. So I know that this has to open towards the left because it's negative. So what we do is we take the value out front, that negative 4, and we set it equal to 4p, which means our p value is negative 1. So that means that my vertex here opens to the focus here. So our focus is going to be located at negative 3 and positive 1. It has to open like this. Remember, I'm not too worried about how wide or how narrow these things open and close. But since this distance is 1, the distance over to the directrix, also has to be 1. Now, remember, the directrix is going to be this imaginary line that kind of counterbalances the parabola. If the parabola opens left and right, the imaginary line has to be vertical. So if it's a vertical line, that means it's at x equals, well, this moved over 1, negative 1. And that's kind of how we set these things up with the shift. Okay. Now, same thing goes through with what we did yesterday. Remember how we did examples where we were given a vertex, let's say at 3, negative 2, and this time we'll have a focus at 3, negative 4. And what we're going to do is we're going to take this information and write it in one of these two forms. So what happens is we have to decide, is it an x squared or a y squared parabola? Now, in order for us to be able to do that, first thing we always do is we rough sketch it. Vertex 3, negative 2. My vertex. And my focus is at 3, negative 4. Now, we know that the vertex always opens towards the focus. So that means this one has to be falling this direction. So this is a down parabola. If it's down, that means it's an x squared parabola. So what we do is we write out the formula. X minus h, quantity squared, is 4p y minus k. Well, we know what our h and k is because we've got our vertex. Our vertex is at 3 and negative 2. So to start out with, we know it's x minus 3, quantity squared, is y plus 2 on this side. Now what we have to do is figure out this p-value. Remember, the p-value is the distance from the vertex to the focus. Well, that's 2, but it went down, so that means it's negative 2. So that means your p-value is negative 2. So you substitute that guy up here, and you get negative 8. And that's how you get this formula. All right? And we'll do one last one real fast with the directrix and see how this goes. So let's see here. Excuse me. Let's say we have a vertex at negative 3 and 1, and a directrix, I'm just going to abbreviate it with dir, at x is negative 8. So, once again, first thing we do is rough sketch. Negative 3, 1, 2, 3, and 1. And directrix, x equals negative 8. Well, that means it's a vertical line because it's an x equals. So here, 4, 5, 6, 7, 8. Okay. So that means that if the directrix is here, it can't open to the directrix. It has to open away from the directrix. So it has to go this direction, which means it's going to be a y squared parabola with a positive value for p because it's moving towards the right. So again, we start out with the generic y minus k, quantity squared, is 4p x minus h. Well, we know that the vertex is your h and k. This is at negative 3, so we have to count how far does it get back to negative 8. So 1 little, 2 little, 3 little spots, 4 little, 5. So this direction was, the p-value is the opposite of p, was negative 5, went that way, which means the positive value goes the other way. 1, 2, 3, 4, 5. So your focus then has a p-value of 5. So now we have our h, our k, and we figured out our p of 5. So we fill it in. Y minus 1. Again, be very careful when you have a y squared parabola. Quantity squared is, well, 4 times 5 is 20. And then we have x plus 3. So give these guys a shot. Again, I'm trying not to make this too overwhelming. I think I threw in there 4, maybe 5 problems for today, all of on formative. So give them a go, and we'll try and go through some ellipses tomorrow. So hope all is well, and we'll talk to you guys soon. Oh, and yeah, let me know if you did not have the apps with conics on your calculator. I'll see if I can figure out a way to send the program to you via an email or so. But I'm pretty sure everybody has that on there. So just let me know if not, and otherwise you're just going to have to write them down. Not the end of the world. All right, guys, take care.